Hey everyone, welcome to this video series that we're going to deep dive and explore a bit more about PostgreSQL, specifically around logs, and just identify like what the real world implications are of these logs. Uh, and in the video series, we're going to kind of start talking about more simplistic workloads, and then deep dive into the code as well, eventually, and kind of understand how transaction isolation also kind of revolves around the same. Um, but yeah, we were going to more specifically talk about access share lock in this particular video, as well as access exclusive lock, and how both of these ends, how do they relate overall, how what's the real world implications of both of them, and yeah, it's just gonna kind of and this is gonna we can look through a lens of a demo, so it always helps understand how everything kind of works. I'm going to have a simulating demo, but right now we can see on screen. Uh, so there is like the um, as you can see, there's like a log defs.h file, which is basically Postgres header file around definition of logs, and it's pretty much like well commented out. Well, you can see that there's like few definitions of the log modes. Specifically, we're going to talk about access share log and access exclusive log in this particular scenario, but in this particular video. But we're going to of course go into a bit more detail in other log scenarios as well. But you can see access share log is like the lowest, one of the, I would say, the lowest level of logs from a client's perspective, because running a select query is something that you would be doing more often when you use PostgreSQL or any database in general. Um, and then there is an access exclusive log, which kind of runs over some critical operations like alter table, drop table. I would say like changing a column, changing the data type of a column, data type of a column. Sorry. So vacuum full operations, right? Like, which basically means that you're kind of removing dead tuples, but like uh, that's like stop the world kind of a thing. You stop having any kind of operations running on the table, clean up the dead tuples, and then release a lock, basically, right? So yeah, what we're gonna kind of look into this is that we're going to kind of try and demo this in a way that we can identify what are actual real world implications of like these locking mechanisms, right? Specifically on access share lock and access exclusive lock, the two variants of lock modes. So let me just open up quickly the demo screen, and let me just clear it up a bit before, because it's easier to follow along. So yeah, what I'm going to kind of show is, first of all, I'm just going to quickly give you what the table, like a simulated table that I have right now in my local Postgres SQL instance. So you can see it's like just a very simple table with ID and name, and just two specific rows. So what we're going to do is just simulate more or less the lock mechanisms on this table. So I'm just going to quickly show one command, run one command, and then show another kind of command. So it's like on the top left, I'm going to run access share mode, simulate a slow query basically. So it kind of, during the beginning of the transaction, it just takes a access share lock on the test table, and then now it waits for 30 seconds. So yeah, this is basically locking the table with an access share mode, which means that on the bottom right, I can just simulate that I can basically select right from another transaction or any kind of just a concurrent like a concurrent process scan, basically, right? Which means every connection essentially is a new process, right? So on PostgreSQL, so that's that you can see that within this access share log as well, I was able to select. And on the left, and the bottom left, you can see that I'm just kind of running a command that shows on the test table what is the type of lock that was granted. Granted is basically a Boolean field, and it's like a true or false, right? So it was granted an access share lock. Again, just to kind of quickly show, if I do smaller variants, you can see two two for the process ID, two different process IDs. They have two different access share lock granted, and I tried to simulate again a slower query on the right just so that I can run this command and show that there's like that the queue has two locks being run. Now the of course the implications of this that if you're running like a big long running query, it should within the context of the table, it should not block any other queries that you want to run if on the same table. Sure, that makes sense, right? Like that's the MVCC for you. But definitely one thing that can affect this is these are the lowest precedence of a lock, right? Access share, and we're going to talk about some normal real world implications of an access exclusive lock, which does happen, right, more often when you kind of do migrations, when you change the structure of the column, vacuum full operations, all of that, right? So we're just going to simulate what are the implications when you have an access exclusive lock. So let me just clear this bit up, and I'm going to simulate on the top right. I'm just going to simulate getting an access exclusive lock mode, and if I just quickly show, there's an access exclusive lock that has been granted, right? So that's fine. If I just quickly run a select again on the right, bottom right, yeah, it's stuck, right? And you can see it's in the queue, until the access exclusive lock gets released, which I'm going to do now, and yeah, it resolved into the query, right? And I would believe there's no more locks being in the queue, right? So that's one thing, and this is definitely one real world implication, that when you take an access exclusive lock, your select gets blocked, which makes sense, right? From a data integrity point of view, if you're changing structure of the column, your select basically would be in violation of that. So and then of course there's the metadata that needs to change when you do the schema changes or DDL operations. So it's super important because it's like something on a storage level as well, right? Now I'm gonna simulate another kind of a scenario. So let's say when you run a long running query, I started running a long 30-second query, which took access share lock again. I'm gonna kind of show it to you. Access share lock, it's gonna take some 30 seconds. And what if I take an access exclusive lock when the long running query is running? Yeah, it never got granted, right? So access exclusive lock is not yet granted because there's a long running query already running. What this means is that any other select query, even if there's not granted a kind of select query on, if the select query is not granted the lock, I won't be able to run the select, right? So I think I have to simulate this again because the 30-second got it was basically finished. So if I just do no sorry, where is it? Yeah, so I've got like a 30-second. Let me just clear this up again. Clear, and end, right? So everything is clean, and okay, canceling, and right. So I believe everything was empty. Cool. Okay. So yeah, let's quickly again do this correctly. Sorry about that. So I'm going to run a long running query, and I'm going to do it quickly so I can see it and you can see it. So you can see access share log granted. Cool. I have running access exclusive log. Yeah, it's not granted. However, right, this is where the things get interesting. More interesting, I cannot select even if there is no access exclusive log being granted. I cannot select because now it's in the queue. So anything that takes precedence is like if there's already an existing access exclusive lock in the queue, whether it's granted or not, the rest of the selects would work, right? So that's another kind of a nuance aspect that you have to understand when you run this run these sort of operations in production. Yeah, what means is that any kind of selects now is no longer gonna work unless and until the access exclusive lock, which got granted now because the above query was finished, um, and it's still no longer allowing a select on the table for this particular process ID. So if I'm just gonna again quickly show, I'm gonna end the access exclusive lock, and there we go, we got a response back, right? No locks. So yeah, as you can see, this is definitely something that at least I find quite interesting when you kind of deep dive into this, when what sort of real world implications of the locking mechanisms that Postgres offers, which is like definitely on the as you can see, it's on the storage level. So it's anything that happens, that these kind of sort of operations that you run can impact your application in production, in real world, right? So it's definitely something interesting to know about. So as you can see, as kind of showed earlier, these are some of the operations that take access exclusive lock. Later down in the video series, we're gonna again talk more about on row level locks as well, and also within the row level, there are different types of locks that get granted. So yeah, we're gonna kind of look into those as well. I'm gonna also kind of work this by an example or a demo, and then we're gonna talk more about transaction isolations and how that also kind of a bit relates to it, but it's the transaction isolation works on an application level rather than a storage level. But we'll see how that's kind of relates to what real world normal use cases look like, right? So and then yeah, we can also try and look into the code as well, how this works, deep dive into Postgres a bit, and try and understand essentially how this is implemented as well, just for curiosity, right? Because it's always interesting. So thank you for taking the time watching this video. I hope you took some learnings out of this, and just let me know if this is something interesting. We can definitely have more and more of such videos later down the line as well. Thank you again, and see you. Bye.